Hello everybody, in this video we're going to start exploring the second type of the discrete power distribution, which is using the mathematical formulas. And we're going to focus on one type, that is the binomial, and I also will mention several other distributions as well, but we will not go further on those distributions. The reason is because the binomial distribution is more popularly used in the business world, and in this first video related to the binomial distribution, I will focus on how you identify the data you're analyzing, the random variable you're analyzing is following the binomial distribution. It is kind of important. And in our next video, the follow-up video, you're actually going to learn how to use Excel to calculate the probability for the binomial distribution. So let's look at, in general, how many different kind of mathematical formula we have to describe a random variable. So how many random variable we have, distribution we have? So like I said, generally speaking, we have discrete random variable and a continuous random variable. Therefore, we have a discrete power distribution and a continuous power distribution. So if we're talking about the mathematical formula for random variable distribution, and we have 6, and we have more too, but here I will talk about relatively popular 6. So under the discrete power distribution, we have binomial, partial, and hypergeometric. And on the continuous power distribution, we have normal, uniform, and exponential. So those distributions, you can find a power distribution to describe it. So we also have many others. So if you really any at advanced business analytics position, and you're also going to see the beta, gamma distribution, etc. Again, here we are looking for basic and the most useful in the business world. So in this video, we're going to focus on our binomial distribution. And so after you learning the Excel part, and now when we move on to the continuous power distribution, and now we're going to look at the normal distribution. So binomial. Before I move on to show you the binomial, and especially the characteristic of the binomial distribution, I want to help you to understand why the characteristic is so important. So my personally, I really love eating apples. I can recognize all kind of different species of apples like Red Delicious, Fuji, Macintosh, and Granny Smith, and without looking at the tags. So I go to grocery store, I can look at the apple itself, and I'll be able to recognize, okay, this is Red Delicious. Okay, this is the Fuji apple, and I instantly had expectation on the taste and the texture of the apple, you know. And so why I know it? Because I remember the characteristics. So for instance, Red Delicious, it's red, and so the texture will be, the taste will be very sweet, but the skin will be very harsh. But if you think about Granny Smith, it's green, and the skin will be harsh, but the taste very sour. So once you remember the characteristic, you will be able to instantly identify what kind of apple you're gonna eat. So the same thing when we look at binomial or partial or hypergeometric or normal, uniform, exponential. How do I know which mathematical formula I should use to describe that random variable? It depends on how familiar you are with the characteristic of that distribution. Therefore, before we look at the formula of the binomial distribution, I have to introduce the characteristic of the binomial distribution, because once you know the characteristic of a distribution, and then when you go to the real business world to analyzing the random variable, you will be able to know whether you should use the binomial distribution. So for the binomial distribution, we have 5 characteristics. First, binomial distribution involving multiple experiments, but for each trial, so each experiment, we only have 2 possible outcomes: success or failure. So here I want to emphasize that the success and failure, sometimes people, because in the real world, we think, oh, success is a good word. How I'm successful, if I'm failed, it's a sad. But in the binomial distribution world, success and failure doesn't mean something good or bad. Success means one of the outcome. Remember, we only have 2 outcomes, right? So one of the outcome you are interested in to figure out the probability. So the outcome you are interested in, so I want to type it so you will take the right note, okay? So the success is the outcome you are interested in and try to figure out probability. Okay, and failure obviously is the other outcome. So you only have two possible outcomes. So if it's not success, it will become failure. So I want to give you an example and ask you to think about it. Okay. So when you are working for the factory, and then if you have some relative work for the factory before, so the most scary thing is the parts you produce cannot pass in the quality tests. So when the government send the agent or you have the auditing people come to your factory, try to check the parts. So what they care about is the defective rate. So how many parts will be defective. And so then they go to the assembling line to look at, okay, let's see 200 parts. So for each parts, they will look to examine whether they are defective or not defective. So basically you do 200 tests, 200 parts for each outcome. So each trial, which means each parts, they do the test. You only have two outcomes, either defective or not defective. So in this situation, which one is my success? Yes, success actually is defective. Why? Because like I said, people care about the defective rate. They want to see how many parts will be defective. So the interested outcome is defective. It is not defective. Therefore, the success will become defective and the failure will be not defective. So this is just one example, help you to understand what do we mean by defective, what do we mean by success and failure in a binomial distribution. So this is the first characteristic. And the second, there is a fixed number, we use n to denote it, of identical trials. So like I said about the assembly line, people try to figure out defective rate, they pick up 200 parts. So basically the same experiment, because they are examining each part, whether they are defective or not defective, but they examine for 200 times. So therefore the value for n is equal to 200 parts, right? And they are identical trial because every time you pick up parts, make sure to check whether defective or not defective. So you are doing exactly the same trials, okay? And then the trial experiment are not typo, IID is called identical, independent of each other. So they are identical and independent. So why it's independent? Think about the 200 parts you are examining. Let's say your first part you find they are defective. Does that mean the second part has to be defective or not defective? You don't know. So they are independent. So that's what do we mean by independent. So identical and independent. And then the probability of success, which is we're using P to denote the probability of success, remain constant from trial to trial. So the P is the probability for your success. So, or the probability for the outcome you're interested in, they'll never change. So for instance, if you think about, let's see, the defective rate is 4%. So every part have 4% chance they are defective. So the first part you pick it up, the value is P. The second part you pick it up, still P. So that's the probability of success. It will never change. It will be a constant. And then the next, if the P remain the probability of success, then 1 minus P, which use Q to denote it, is a part of the failure. So basically, the P and the Q, the P, the probability of success plus the probability of the failure should equal to 1. So that is the 5 characteristics we need to identify before we believe we're dealing with a binomial distribution. And later, I'll show you an example to help you to practice to identify these 5 characteristics. So here is more experiment, the trial, independent trial data indicating it is satisfied the first condition of the binomial distribution. So the first condition is you only have 2 outcomes, okay? A manufacturer plan label item as either defective or acceptable, 2 possible outcomes, right? Defective and acceptable. And usually we treat defective as my success because that's the probability we usually care more than acceptable, okay? A firm beating a contract either get the contract or not. Again, 2 possible outcomes, get or not get. And a marketing research firm receives survey response, yes, I will buy, no, I will not. So 2 possible outcomes. And then new job applicants either accepted or reject offers. So again, 2 possible outcomes, accept or reject. So this is the example that to help you understand 2 possible outcomes. So after we know the characteristic of binomial distribution, the next we're going to look at is how this binomial distribution function look like. So this is how our binomial power distribution look like. I don't want you to really memorize how this formula look like. I just want to help you to identify what kind of information we need to calculate probability for the binomial distribution, because all the calculation will happen is on Excel. That's what we'll get our focus in next video, how to use Excel to calculate probability for the binomial distribution. In this part, we only focus on, okay, how this binomial distribution really look like. So look at the right-hand side. Right-hand side, how many unique English letters do we have? Okay, 1, right? 2, 3. That's it, right? We only have 1, 2, and 3. So basically, after you read the case, if you identify 3 values, you will be able to calculate the probability. Okay, if you can identify the 3 values, you will be able to calculate probability. So now let's look. The N is number of the trial, P is the probability of success, and X is the number of success. And so the Fx is the probability. So basically, after you read the case, you should identify the value for N, P, and X. So once you identify them, and you will be able to calculate the probability. So to give you more detail, more understanding on what we're really calculating here, so the right-hand side here is the number of the experiment outcome providing exactly X success in N trial. On the right-hand side, so P is the probability of the success and powered by the number of success. And 1 minus P is the probability of the failure and then powered by the number of the failure. So basically, we try to see the probability of one situation happen. So So let's think about this case. I want to ask you the thing. You are taking an exam. You have 100 questions in the exams. 100 questions in the exams. So they are all multiple choices. So for each multiple choice, you have 4 options. 4 options. And then you just go to take the test, randomly guessing all the questions. So the question is, what's the chance for you to be able to pass the test? Let me repeat, 100 questions, and then for all 100 questions are multiple choices, and so each question has 4 choices. Only one choice is right, and then you just randomly guessing all the questions. What's the chance for you to pass the test? So first, after you hear this question, and I want you to think about, do you think this case satisfies the binomial distribution's characteristic? So we said, okay, binomial distribution first. For each independent trial, we only have 2 possible outcomes. Is that true? So think about how many trials we have here. We have 100 questions. So for each question, you are guessing. So basically, you did 100 trials. So for each trial, you are guessing a question. So one trial is guessing question. So how many outcomes you can get? Yes, you either can get it right, you get it wrong, right? You guess it. You guess it right or you guess it wrong. So therefore, the 2 outcome is you guess the 1 question right and the wrong. So now the question is, which one is my success? Of course, success is right because remember, we try to figure out what's the chance for me to pass the exam. So which means we have to get as many right questions as I can, okay? So now we know that we have success. So how many independent trial do we have? You're right. N equal to 100 because we're guessing 100 questions. So N equal to 100. And so then the second information we need to identify is P. So P is the probability of success. So basically, what's the chance for me to randomly choose one question to guess it? What's the chance for me to get it right? As I said, we have 4 options. Only one of them is right. So that will be 1 over 4. So that means I have 25% chance to get one question right. Okay, so this is probability of success. So think about the characteristics of binomial distribution. So they have to be independent for each trial. Basically, if I got the first question right, does that mean I will get the second question right? No, you got first question right. You still need to do the same experiment again to guess the second question. The chance for you to get second question right is still 25%. Therefore, the P equal to 25% will never change. So you know N and P. So now what's the value of X? Remember, X is number of the success. How many number of success we're looking for? We're looking for what's the chance for us to passing this 100 question exams. So all the exam is if you pass 60 and you pass the test, right? If you get at least 60%, you pass the test. So therefore, the number of the success we are looking for is X larger and equal to 60. Now we had all the information we need, the value of N, the value of P, and the value of X. And then don't worry about how to get the probability because in our next video, after you know this full information, you actually can use Excel to help you to calculate this probability. You literally can figure out what's the chance for you to pass the exam if you literally guess all the questions randomly. And so that is next video we're gonna learn use Excel. But in this one, we just get familiar with this binomial distribution. Okay, before we end, I want to add one more information, and that is another incentive for us to identify the binomial distribution. So after you know the distribution is following the binomial distribution, you will be very quickly to obtain their expected value, variance, and standard deviation. Remember, in last video, when we look at the general discrete distribution, we actually have to use that sum x fx to get it, right? And so actually it's a lot of calculation. However, if you know the random variable is following the binomial distribution, the whole calculation will be much, much easier. So if x is followed by normal distribution, the expected value of mu will equal to n times p. So I hope you can remember this formula. And then you can ask me, Dr. J, how I get this value. Actually, there is a long mathematical process to prove this original formula equal to this one because we're dealing with a binomial distribution. So this formula only works for the binomial distribution. If you are not sure you're dealing with a binomial random variable, please don't use this formula to calculate expected value. You still need to use this one, okay? And so the same, if you know this is a binomial distribution, the variance will be able to very quickly calculate it using n times p times 1 minus p. So the number of the trial times the probability of success times 1 minus the probability of success. And then you take the part square root of your variance, you got standard deviation. So this is the extra bonus of knowing you are dealing with a binomial distribution. You can very quickly to understand where is the central location and the variability of your random variable. So this is the end of this video. In next video, we're going to learn how to use Excel to assist us to calculate probability for binomial distribution.